Hey guys, your boy Chili coming back at you with some ROM hacking on the Warriors of the Eternal Sun for the Genesis. This is where we left off. Since then, I've done a little bit of reverse engineering off screen, and I just like to share my results before we move on here. So after you do the strength bonus, what you're gonna do is you're gonna again look at the target's character sheet, and again this mystery double word here, it's mystery 32 bits, and you're gonna basically what this is doing, this is inspecting the very first bit 0, and if that bit is set, the result of this AND is going to be non-zero, so we don't take this branch and we subtract 2 from the value that we rolled. So this is applying, a static debuff to the active character's roll only if they meet this condition. And what I've noticed is that all the player characters, they get the debuff. I haven't actually tried with the monsters yet. That might be a good thing to test. But it's kind of a dick move, right? Just to subtract 2 for your roll for no reason. I don't know if that's part of the D&D rules anywhere. But one thing that is a little interesting here for me is essentially what they're doing is they're testing a single bit in this 32-bit value at this address, right? I wonder why they move and then do and then branch if equals. Like here they do and, but here if they're testing a single bit, they use, the special purposed instruction for that reason. You test a specific bit. So I don't know why they do it one way here, they do it another way there. It's mystery to me, but I guess it's not that important. The important thing is after you debuff the roll, these 2 sections here are very self-explanatory. Basically, they're clamping your roll value between 20 and 2. So if after all the things have been applied, your target is greater than 20, not your roll value, your roll target. If that's greater than 20, it's reduced to 20, and if it's less than 2, it's brought up to 2. And what that is doing, essentially, what that says, is that no matter how many debuffs you get or whatever, you always have a chance, right? You never have an impossible target. If you roll a 20, you will hit. And likewise, you never have something that you can never miss, right? If your target goes down to 1, then any roll you make would hit it. So this is saying it has to be at least 2. So if you ever roll a 1, then you're not going to hit. And then you're gonna do the check. This is the moment of truth. You do a comparison, which is essentially saying subtract target value from your roll value. And if your roll value is greater than or equal to the target, then we're going to branch here. That means you've succeeded in your attack. Otherwise, this is what happens when you fail an attack. Let me see here. You're going to clear out D0, which is the return value. And SF is weird. This is set but fail. Set flag but fail, I don't know, but I think what this one does is it actually clears out the memory. Clear out a global flag, so it sets it to all zeros basically, and then you return. So you're gonna return 0 in D0, and you're going to set this global variable to 0. Now if you succeed, you're gonna set the return value to all ones, FF. It's setting a byte. Here it clears long, here it sets a byte, whatever, sure. Okay, so you set it as a byte, but then you extend it to word size. I don't know what they're doing here sometimes. And then you return. So if you succeed, it does not do anything with this global memory, but it does change what is returned in D0. So this return value is very important. And already we can understand something very important. This algorithm here, this function, does not handle the consequences of an attack if it succeeds. It does not handle, damaging the enemy, calculating how much damage is done, subtracting the HP, etc. So that is done after we return from this function. Very good to know. But yeah, that's basically it. There's a special case for melee that was tested. We can check it out here. So that's this test here. And that has a special case. I don't know what's going on here, but you do some stuff and then you go up to the part where you're going to roll. So you skip the hit table bonus, but you're doing some other crazy shit. And I'm not going to worry about this right now. We'll look at this one later. We'll try to figure out when it applies. The other special melee thing, which comes in this test here, it's testing whether these two bits, either of them have been set. And this one is interesting. What it does, it's accessing A2, which is somehow related to what action you're taking. It's incrementing it, and it's moving that value into its D0, which is the return value of this function. So it's saying the return value of this function, well, okay, it does that, but then it immediately writes over the value that was loaded from here. So it loads a value, and then it immediately ignores that value and just sets it to FF. So what this special one does is it always hits. If you hit this case, you're always going to score a melee hit. And I don't know if that's intentional. This could be a programmer bug, because it looks like they're loading some value from the action information, and maybe that was supposed to be the return value, but then they overrid it because they kind of sucked in this instance at programming. So, interesting things to look into, but I think the most important takeaway is that when all is done, if you hit, the return of D0 is FF, and if you miss, the return is zeros. And so what we want to do now is after a hit and after a miss, we want to return from this, see where it goes, see what happens next, and try to find the place now where damage is calculated, because that's the other side of the equation for melee. Let's see what happens now when we hit. Where do we go? All right, tragedy has befallen the party, but let's see if we can get a little bit of vengeance. So take this. All right, so we rolled a 5. Not good. Let's see if we get a bonus. No bonus there. No bonus there. Oh, shucks. Well, maybe we'll get a good strength thing, I think. So where does the strength come in? That goes into D1. And then we do the lookup, and we add to D0. Oh, it became 8. We got 3 additional from the strength. Still not enough to hit this son of a bitch. Now here comes the shenanigans. Subtract 2 just because. Now we do our range testing. And now we're going to, the moment of truth, compare D2 with D0. Do D0 equal to, what's like a big number? 10? Okay. How you like me now, bish? F10. Step over. Branch if greater than or equal to. And we branch. So we set D0 to FFFF. Or just FF. We extend that to FFFF. And then we return from subroutine. So here's where things get interesting. Where do we go? We go to 13AFE. All right, so now we're doing a comparison. I don't understand. Negative OX800. What does that even mean? I don't even know how to compare that, but let's see. Let's see how it compares. So we steppers, and we branch equal to 0. I mean, that's not going to be equal, right? So I guess if the return value was exactly this, we would go to this branch, but that's not it. Now we're comparing A2 with A5. They both seem to be in pretty close areas. So they're both things that are pointing to stuff in that action table. So we compare. We branch if they are equal, but they are not equal. We move D0, which is the result of that action, into D1. And then we branch to AE0. Where's that? Where's that in relation to that's back up here. So this is a loop. Let's just call this action loop. Interesting. And then it's going to increment that action pointer again, move that into D2, check if it's exactly 7, check if it's exactly 0, and if so, branch out. But if it's not 7 or 0, we're going to load into the jump table again. So now you got my ass thinking. You got the gears working, because this doesn't seem like A2 is just pointer to whatever action. This is like a scripting engine, a software interpreted script that they've built, and A2 is pointing to the next thing to do in memory or some attribute of that thing. And so you're constantly like incrementing A2 and then doing whatever is at that address, doing some action based on that, and then increment again and see what it is and do some more stuff. So this is like a state machine scripting engine, maybe. So we have, this is the jump table, which is indexed into based on something stored in this A2 table. But what is where is the A2 table? Well, if we look at the value of A2 right now, 3EA97. So, I mean, already we see there's like something interesting going on here, because like the data seems very structured, if you know what I mean. And it also seems like it is exactly aligned 16 bytes. So like every maybe entry in this thing is 16 bytes long, because like look at how nicely the rows line up. There's no staggering or anything. So interesting. Okay, this is complicated, but anyways, so we go back here. So let's see if we hit this check for F. Check for 0. Where is D2? D2 is 16. Let's say F is 7F. There's like, it's checking if it's 7F or if it's 0. So that goes there, test that, that's not 0. So now we're gonna scale D2. What is D2? 16. So we're gonna multiply by 4. So now there should be 4O hex. And that is our offset into our table of pointers. Here we get our offset, and then that's where we're going to jump into. So here's where we go. And this should be handling stuff that happens after melee attack. Address is 14102. It's called a label, but it has a return from subroutine, and we jump into this place. So this, we're not going to call this a label, we're going to call this a function. So we call it melee try aftermath, and the reason why I'm naming it this is because this is the place where it actually checks the result. So no matter what happens in the previous script function, it's going to come here. This is a very short one, as you can tell. It just does a test. So D1 was moved from D0, and so that was the return value of our melee, I forget what it called, do melee something. It's called do melee accuracy. I should probably change my naming convention to show to differentiate the ones that are like script functions. But for right now, I'm just going to call this one melee try aftermath. And so we test W. We branch. Maybe we branch if it's a miss. B equal TST. So I think you branch if it's 0. Well, let's see here. So we test D1. D1 is currently FFFF, which is the return of the previous thing. We test it. The 0 flag is not set, so we shouldn't branch. We should just return. And yeah, there we are. 106 return. So this here, we're branching if melee hit. This is okay. So this function does handle the damage logic, but it also checks to see. So it goes here either way, and here it does the check. And if there was a hit, it handles the damage. I think that's the way it is. So I call it do melee aftermath instead of do melee damage, because it might not be doing damage. So branch if melee hit. Okay, this is interesting. Now it moves that special value that was being compared for into D0, and then this one returns as well. Okay, so this one does not handle melee damage. I could have just looked 2 instructions further to see that this is not a good label. Do melee accuracy result check. There we go. Okay. So I don't know why they have a special function or in the special entry in the script just to do this test to bring it back. But I mean, they probably have their reasons, right? I'm not going to judge it at this point. I'll judge it later when I know more about it. And then I'll say, yeah, that's stupid. Compare. Wait a minute. 13AFE. So we're back. Yeah, I stepped a little further than I expected to. So let's go 13AFE. We're back here on our bullshit. Now we're going to compare, and it is going to be equal. So I don't know what this means, but in our case, it at least means for melee that a melee had hit. I don't know if this loop is only for melee or only for attacks, or if it goes for all functions. Yeah, I'm pretty sure I came into here from like magic and also from other actions. So I don't think this is just for melee, although there is a branch where we can escape. Where does this go? Yeah, where we escape the action loop. So maybe some of that stuff wasn't going in here. So we can look at that later. That's not important for right now. Where are we right now? We're in the comparison. Yeah. Okay, so now this should branch. So if I go F11, we should be going to B44. Wait. No? D0. F. Why is it F? Wait a minute. I'm getting confused. Didn't we set this? No. This is if it did not hit. Melee. Ah, right, because we branch here, but we test, and we branch if it was 0. That's why I returned unexpectedly, because my brain had gone down the wrong branch. So this is why it would be nice to connect this directly to the emulator, but it's just such a shit show. I'm not gonna go through that bullshit. Melee did not hit. So if it did not hit, then we do this in there, and then we do something else. So we're doing another iteration of the script. Okay, so we do this A2, A5 comparison again. It should not branch. We move D0 into D1, which is again FF. Not gonna think about that too much right now. Branch if equal. That doesn't. Did that happen? Oh, that's just a branch. Branch to action loop up here. That's a move B. That is correct. And then we increment A2 again. So yeah, we do the next thing. Do our comparisons. We don't branch. We test. We don't branch. Test B, D2. Nope, don't branch yet. And so D2 is a 2. Multiply that by 4. We get an 8. So now we're jumping into new thing, 13CEC. Keck. Let's do this. All right, another label. This is also a function. So this one, do melee damage. That's what we're calling it. It might not be the case. There might be more bullshit, but I got a good feeling about this one, guys. This is where it is. We've made it. All right, so here we are. We're loading, looks like some more parameters from the action script into D0 and D1. Do a sign extension, so I have no idea what those parameters might be, but I'm going to sign extend the one in D1 to a wide boy, and we're going to compare that with a memory address, a global that we have encountered before in the melee accuracy. We did a comparison with this one. I don't remember where we did the comparison or in what context, but we did do a comparison there, and we branch if that's not equal to 2. So if that's not equal to 2, we do a branch. Otherwise, we're doing the same range check that we did in the accuracy. We branch if it's less than, or we branch if it's greater than. So if it's within this range, and it was within this range when we were attacking with a character, then you can catch our ass doing this stuff. So let's see if it's a 2 in here, then we're going to branch to some D2. Oh, otherwise we're going to branch to, I don't think we're going to hit this one. We might branch there. Let's take a look. What's in D0? What's in D1? What's behind door number 2? So in D0, we've got FF16. Well, no, we got 16. The FF is just garbage. And D1, catch us with a 0, 0. We extend that, which will 0 out the top byte in that word. All right, now we're going to compare with 2. Compare the byte 2 with whatever's in that memory address. We did not branch, so whatever that thing is storing, who knows? It's not, we're not it. All right, so these ones are not going to hit because we're a character. I don't think they're going to apply, so we don't branch, and that means we're doing stuff. So here it looks like we're saving something on the stack as a local variable. Ghidra has identified that. We're gonna squirrel away this D0. It's important for reasons, apparently. So we'll put D0 onto the stack, and then we're going to clear out D0. Then we're loading. I keep forgetting, is A3 the character, or is A3 easy enough way to find out, I guess? What is A3? I wish we could just copy from here. FF912C. So that is the active character. I just had some function parameters in here to make things a little prettier. Yeah, so we're doing script, where was I? Yes, okay, so now we can see that they are loading the strength, and they're doing the strength hit bonus lookup again. So they're using that table as well somehow for damage calculation, which I don't know if that's kosher either. But yeah, here we went below 0. We're going to bring it up to 0, but we skipped that otherwise. Now we're moving minus stack point. That's the local 2. Now we're restoring that into D0 after we've done this. So D0 contained some kind of parameter from the script. We squirreled it away. We're restoring it. We're looking into another field in this data sheet that I have no idea about. And we're adding that to parameter from the script. Now here we can see we're doing our roll. We're going to roll the dice again. So this seems like this would be our roll for how much damage we're going to do. And these D1 and D0 are adjusting the range maybe of that roll. All right, so D0 and D1 are parameters loaded from the action script. We have squirreled away D0. And we're now going to add a strength bonus to D1, which when we loaded it was just 0. So we add to D1, we get 3 for the strength bonus based on the table lookup. And then we restore D0, which was FF, well, it was just 1/6, I guess. So now there's this field in the character sheet, and we are adding byte from that field to D1, and there was nothing in there. So, okay, fair enough. No bonus for that, but that's some kind of damage bonus. I wonder... Yeah, let's add that as damage bonus in here, since that's the only known use for this entry at the given time. Well, this didn't update. Field 91, right? OX91 is not field. Yeah, okay. Fair enough. Good. So that would be OX6E. This one here. Byte. Damage. Yes, save that. There we go. Damage bonus. Okay. Since I have no idea what else this could be, that's what we're gonna call it for now. Okay, move A. Oh, so we're moving into address now. Interesting. I think I do recall A0 being perhaps a parameter to this function. So it looks like it's being used here. We're moving D1 into there, which is a 3. Interesting. So now we might have to actually start to reverse engineer this now to understand, because I know there was the range that we passed in the other one. Let's take a look at that for a second. Yeah, D0 and D1 for range seem to indicate the low and the high, although we could test that. And then A0 is just a question mark. We don't know what this does. But they do seem to be setting up D0, D1, and A0 again in preparation for calling the dice roll. So we move just a global, not dependent on, well, ostensibly not dependent on, which character is doing the attack or anything. We're moving some global into D1. Yeah, so D0 is begin, D1 is end, and we're moving this global value into D1, sign extending it, adding that to A0, Then we move D0 into D1. So this was all just to add to A0. Yeah, we load this, extend it, add, and then we're moving D0, which is a 16, into D1, and then making sure that, oh, but interesting, 1/6, not 16, 1/6 hexadecimal, masking it to the nibble, divide D0 by 16, mask it. Very convoluted. All right. Global melee damage roll. So this thing is some kind of global memory that's involved in melee damage rolling. So we move D1 into A0. Then we move this into D1. We extend that. Then we add that to A0. Then we move D0 into D1. So D0 affects the range of the roll since it's copying over D1. So whatever's in here at this point, which was set up that was just popped off the stack here. So D0 was just set up here and never really touched. And that controls the whole range. So the plus and the minus. And then A0 is being controlled by a whole bunch of stuff. Interesting. D0 is being divided by 16, and that value just by itself is going into D1, but they're both being masked to the low nibble. So maximum is 15. It ends up being values between 0 and 15. All right, so let's see here. D1 is a 3. That goes into A0. We move some mystery global into there. We extend it. We add that to A0. It was 0, so nothing changed. We move D0 into D1. So now they're both 1/6. And then we're going to mask it out. So that's just 6. Now we shift right, dividing by 16. So 16 divided by 16. No, 1/6 divided by 16 is just 1. Okay. Mask that. And then we jump. So in the end, it's a roll between 1 and 6, but in A0 is a 3. And let's take a look at this one again. Yep, beginning range. So it's a roll, damage roll between 1 and 6 with A0 having a 3, which might just be like a value that's added on. In which case, why does it even need to pass that into the function? You could just add it on after you've done the roll. Just seems like an unnecessary feature for that function to have. But maybe A0 is doing something more interesting. So I think in the next video, we're going to do a little deeper dive on this ranged RNG, because there's more that meets the eye. This function calls some intermediary RNG function, which then calls the random engine, right? And both of these intermediate functions are doing stuff before and after their calls. So there's plenty of shenanigans going on here, and I didn't look very deep into it because it seemed very simple at the time. But now, since we need to understand what A0 does, we're going to have to dig into that.